Hello, good day, children. We are going to learn mathematics, and the topic is binary number system. All this we'll be learning in decimal ordinary numbers like 0, 1, 2, 3 to 9. So today we want to look at another way of explaining numbers. In binary, the base equals 2. So when we talk about binary numbers, we only count zeros and 1. For example, most of our electrical appliances, we are using this concept to operate our electrical appliances. For example, this switch here, if you look at the switch, we normally have 1 and 0. That 1 signifies switch on, while the 0 signifies switch off. So that is the concept we're going to look at here. And the two digits are 0 and 1. So in binary, we count only in zeros and 1. There is no other number. So we're going to count only zeros and 1 in binary. Example A, we say that we are going to convert this conversion from binary to decimal. Another name for decimal is denary. So denary means counting in decimal. So in this case, we're going to convert from binary to decimal. As we see, just look at the board. Here, this is what we normally do. This binary is in base 2. It's always in base 2. So we're going to convert from base 2 to base 10. And what do we do? What we do is that we start from the first digit. And the first digit here is 1. You write there 1 times the number of base, the base. The base here is 2. Then you count the remaining digit. We have here 1, 2, 3, 4, 5. That is going to be power 5. Then we go to the next number plus the next number, which is 0. You write there 0 times the base, which is 2. Then the remaining digits 1, 2, 3, 4. Write there 4. And the thing is decreasing in serially. Then the next one is 1 times the base, then power the remaining digit 1, 2, 3, plus the next digit after 1 is 0 times the base raised to power 2, then plus the next digit is 1 times the base raised to power 1, and the last one is 1 times 2 raised to power 0. So from here we're going to expand these values now. 1 times 2 power raised to power 5 is the same thing as 2 times 2 times 2 into 5 places, and it's going to give us 32 plus 0 times 2 raised to power 4 is 2 times 2 into 4 places, and it's going to give us 16 plus 1 times 2 raised to power 3 is going to give us 8. Then we have here 0 times 2 raised to power 2 is 4 plus 1 times 2 raised to power 1 is 2 plus 1 times. In this case, any number that is resting to power 0 is always 1. Take note of that. Any number that you see resting to the power of 0 is always 1. So that is very important. You don't need to forget that. So let's look at this. 1 times 32 is going to give us 32 plus 0 times 16. Any number multiplied by 0 is always 0. Plus 8 times 1 is 8. Plus 0 times 4 is 0. Plus 1 times 2 is 2. Plus 1 times 1 is 1. So by the time we add all of them together, we're going to add 32 plus 8 plus 2 plus 1. And our final answer is going to give us 43. If you add these together, 32, 8, 2, and 1 all together, is going to give us 48. And you always remember to write the base. Remember, we were told to change from binary to denary. So denary is base 10. You write 10 there, just as the subscript. That is how it is written. I believe. Okay, so let's quickly look at the example 2. Example 2 says, convert 100101 to denary number. Remember, I told you that denary is decimal. So we're going to convert. Denary means base 10. So we're going to convert this. This is already in base 2. We are going to convert it to base 10. So we're going to use the same method we used in the first one to solve this. Remember, I told you we always start with this, the last digit here, which is 1. 1 times the base, which is 2, raised to power the remaining, you count the number of digits, 1, 2, 3, 4, 5, plus the next digit is 0 times the base raised to power 4, plus the next digit is 0 times the base raised to power. You can see the number is decreasing from 5, 4, the next number will be what? 3. Then you take the next digits, always add them. The next digit after 0 is 1 times the base raised to power 2, plus the next digit is 0 times the base raised to power 1, and the last digit is 1 times the base raised to power 0. So let's expand it. 2 raised to power 5 is going to give us what? Going to give us 32. So 1 times 32 plus 0 times 2 raised to power 4 is going to give us 16, plus 0 times 2 raised to power 3 is going to give us 8, plus 1 times 2 raised to power 2 is 4, plus 0 times 2 raised to power 1 is 2, plus 1. Remember, I told you in the first example that any number is raised to power 0 is always 1. So don't forget that. So we have 1 times 32 is 32, plus any number multiplied by 0, always remember that is 0, plus 0. Then we have here 1 times 4 is 4, plus 0, then plus 1. So let's add it together. If you add 32, 82 plus 4 is going to give us 36. Then 36 plus 1 is going to give us 37. And don't forget to write the base. It's very important. Now remember that we are converting to denary number, and denary I told you that is base 10. So always remember that. That is how it is done. I believe that is clear. Now to convert from binary to decimal. Invariably, we're going to convert now from decimal to binary. So this is the way through which we can convert it. The example 3 says convert 5 in base 10 to base 2. So we are now going to convert from base 10 now to base 2. This is the method that we are using. You just draw a straight line like this. You put the 5 here. Since it is base 2, you divide everything by 2. So 5 divided by 2 is going to give us 2. Remainder 1. You always write down the remainder. Then we take 2 again. 2 divided by 2 is going to give us 1. Remainder 0. Because 2 divided by 2 is 1. There is nothing that remains. So you write remainder 0. Then you take the last one, 2. 1 divided by 2 is 0. Remainder 1. So these are the numbers, the binary number we're going to look at. We normally use arrow to point it like this. Why did I write the arrow pointing upward? It means I'm going to take my binary from the down to up, from the last number here to the up number. So the first binary number here is 1, the next one is 0, the next one is 1. Remember the base, we are converting from base 10 to base 2. So you write here 2. So this is how to convert from denary to binary. Is that understood? Okay, let's quickly look at the next example, example 4. It says convert 87 in base 10 to base 2. So you write the 87 inside there. Remember what I told you in the example 3? You divide everything by 2 because it's a base. We are converting to base 2. So you now say 8 divided by 2 is going to give us 4. 7 divided by 2 is going to give us 3. Remainder 1. Always remember to write the remainder. It's very important. Then you take 2 again. 4 divided by 2 is what? Is 2. 3 divided by 2 is what? Is 1. Remainder 1. So you go to the next one. Use 2 again. 21 divided by 2 is going to give us 10. Remainder 1. You take 2 again. 10 divided by 2 is 5. Remainder 0. You take 2. Always use the base, which is 2. 5 divided by 2 is going to give us 2, remainder 1. Then you take 2. 2 divided by 2 is 1, remainder 0. And the last one, 1 divided by 2 is 0, remainder 1. You write the arrow facing upward, then you count your binary from down to up. So the first binary number that we have here is 1, 0, 1, 0, 1, 1, 1. Then you remember to write the base. We are converting from base 10 to base 2. So this is how to convert from base 10 to base 2. So if maybe at the end of this you don't understand, go through from the example 1 and study it again with understanding. By the time you study it again and again, you're going to understand. At the end of this class, I'm going to send the assignment. Make sure you do the assignment and submit it on time. Thank you very much.